but now we're going to be looking at assignment-related maths. Oh, you speak English, don't you? Yeah. Assignment-related maths. You know assignment? You know maths? And you know related? Great. So page 46, Karar. Page 46. Yeah. Now, to get you started, I think, this is a new topic to the course. It's new to the syllabus, new to the course. Your assignment is about this topic and about the next topic. I don't really want to do both topics today because there might be too difficult to do both today. And in fact, I think this is probably new for most people, this topic. So anyway, to get us started, what I want everybody to do for me is try and calculate something like this. Yeah. No. No, it's up here. Try and do this for me.
EX squared.
Yes. E to the x, the 2 to the k to the j. Now, actually, I like that now. E to the x to the 2 to the k to the j. There you go.
KC was better.
Nah. K to the j. So what method are you going to try here for integrating? Is it what method? You're going to try substitution, yeah?
This assignment, 3 weeks, 2 weeks?
I keep forgetting to check the calendar. What I would love to do if I could, but I don't know if I can, is give you the Easter break as well to work on it. But I don't know if that's possible, because you also have chemistry stuff, don't you, or something?
Yeah.
When's the chemistry due?
21st March.
Is that before or after Easter? I don't even know anymore.
Before. Well, that's first draft.
Oh, there's only a draft.
Yeah.
I have to check.
She won't accept.
Oh, I've no doubt about that. So I need to check with Connell about what date I can pick. I'll try my best to give you as much time as possible.
And this time, could you like the last time in math assignment, you just said, go, that's fine. Something that you didn't just give us like straight.
No, I can't help you too much. I mean, I can give you guidelines, but I can't. It's supposed to be independent work, so I can't be.
But like Lori.
No, don't compare me to Lorraine. I'm nothing like Lorraine, okay?
Okay.
Firstly, alright, I've brown hair, she has blonde hair, okay?
What teacher can do?
But we're totally different teaching styles, yeah?
But it's allowed,
Oh, it's not about allowed, it's about what I believe in, yeah? So she believes in one thing and I believe in another thing, okay? So I don't want to be telling you too much what to be doing because I feel like it destroys your brain. I want you to think independently and work independently, and I'm here to guide you. I'm a guide. I can say, maybe you want to go this way, maybe you want to go this way. I'm not a coach, I don't say do this, do this, do this. because I think it's important that you try some things yourself. Some of them will work, some of them might not work, but this is how you grow as a person, okay? Right, did you get an answer here yet?
No.
Okay, I'll stop you and put you out of your misery now.
I'm done.
You done?
Yes.
Alright, impress me.
Question is in the liver.
Show me what you got. Give me that. Did you get an answer over there?
Yeah.
You changed this x to u. How'd you do that? Oh, so that's a root u. This is u power a half. That's u power minus a half. Anyways, it doesn't matter. That does not integrate to that. Because this is by parts. It is a multiplication. Yeah? Yeah?
Yeah.
By parts agreed, so everything from here down is wrong. And that's a minus. Anyways, I'll put you out of your misery. This here, the answer is...
Cannot solve.
Cannot solve. No. This here has no solution. Now, what I mean by that is, of course, it has an answer. There is a number answer here, but there's no mathematical technique to get to the answer. That's what I mean. So this has us in an interesting situation. We have this problem. This problem has an answer. It has a number answer. Okay.
Who got that?
I think this would be maybe Gauss, possibly, maybe 200 years ago. It has a number answer. It does have an answer, but we can't find it because there's no mathematical method to get to the answer.
Oh,
Huh?
he got it. Oh, he got it.
Oh, this is what I'm going to show you, okay? So, we need a new tool, a new technique. So, this is continuing our numerical methods. So, do you remember with Newton-Raphson? Newton-Raphson was a method to get to the root. Now, was it perfect? No, it had some problems. Like, for example, it only gives you one root. And sometimes you have to try many times. And it doesn't give you the exact answer, it just gives you a good estimate of the answer, okay? So this is all part of numerical methods. So we are going to look at a numerical method called well, I don't really think this is the correct adjective. I call it Trapezium Rule, but I think it should really be Trapezoidal Rule. So Trapezium Rule, it's a method for integration, okay? So this is what we're looking at. Let's have a look at the rule. So do you remember, what does integration represent on the graph? So if I'm here at A and here B, yeah, good, it's the area, isn't it? So if I want to, if this is my fx, and I want to integrate fx dx from A to B, what am I really looking to get? Area under the curve. And this is the problem I gave you a minute ago. Is there a graph for ex squared? There is a graph, of course there is. The graph will look something like this. Will there be an area under the curve from 0 to 1? Of course there will be. So of course there's an answer. Not only is there an answer, I can estimate the maximum the answer could be. You know, if I was to put this in a box, I could say the answer must be less than this box because it fits in the box, you know. So how big is this side? 1. And how big is this side? It'd be e power 1 power 2, which would be e. So what would be the area of this red box here? 1e, which is 2.718. So not only is there an answer, and not only do I not know the answer, I can even tell you what the answer must be less than. The answer must be between 0 and 2.7. But I don't know what it is. So this method here, it's a way to estimate the answer. Estimate. What you do is you imagine you draw a straight line from A to B. So it's not a curve anymore. It's now this trapezoid shape. Will that be accurate? Well, It'd be close, it won't be perfect. Okay?
It's more accurate than curve.
The curve will be more accurate. Oh, what are you saying?
Opposite.
But there is,
This will be easier to calculate.
Yeah.
And it's not quite, but it's almost equal to the original area. There's a bit of an error here.
but there is, like the formulas to calculate this type, like the half circle thing. To calculate
Yeah, but it's not really a circle shape. It just is a curve shape. Anyways, if I was to make it this trapezoid shape, what would the area roughly equal? Well, it's equal to a rectangle
But there is a formula
plus
for
a triangle.
There's a formula for trapezium half.
Ah, yeah, but because I haven't done that, I'll do it as two parts here. There is correct
Yeah.
formula. So it's the base. How big is the base?
A,
No.
B minus A.
B minus A. And what's the height here of the rectangle? The height here? That's FA is the height here at A. And what's the height here at B? Well, FB. Yes? Okay? So what's the height of the rectangle? F.
B minus.
No, the rectangle.
Oh,
FB.
Try again?
FA.
Yes, because. Is it? Now, what's the shape on the top? Triangle. So the formula is half the base, B minus A. And what's the height?
No, FB minus FA.
Very good. FB minus FA. Now look, because this is part of your assignment, I want you to make good notes of this lesson. So we'll just stop for a moment for you to write this down. Like I said, there's only one topic I need to get done today, so we won't rush.
It's basically the formula.
Well, we can simplify it a bit, but it's the first step there. Did you write this down, Yemi? Yeah? Yeah? Okay. So, let's see if we can just clean this up a bit. Well, there's definitely a B minus A we should take out. So B minus A comes out. And the first term will be FA. FA. And the second term will be a half FB minus a half FA. Because I can multiply the half in. Now what happens here? FA minus a half FA. What's that?
Minus half
Yep.
Okay.
half FB.
FA minus a half FA is a half FA plus a half FB. Now what's in common? The half. So you can take the half out. So you have a half B minus A times FA. And you know what? I'll write it backwards so it matches up. So FB plus FA. Yes, yes, yes. these are all notes that you could put into your report, because as part of your maths assignment in semester 2, you're going to need to use the trapezoidal rule, which I'm getting to now. Yeah. Continue. So you might think, oh, well, that's great. I have a rule now that estimates the integration.
Why can't it be called something easy like perimeter with triangle or something?
Because you ain't in middle school no more. That's why. You said perimeter of circle. No, was that your suggestion, was it?
Triangle.
Triangle. Oh, not even a circle. Oh, man. All right. So you might think, all right, this is great. I have a rule now to estimate the area. But we can actually improve the rule, because if you think about it, what this rule is doing is you're taking a curve, you're taking an A, you're taking a B, and all it's doing is drawing a shape like this to get the area. And you think, that's okay, but you can see there's a bit of an error here, there's a bit of an error here. It's not perfect. So how could we improve this rule? Well, actually, just before, no, actually, we'll just continue with the graph. So what do you think? How could I improve this rule? I have an A here
B here.
and a B here. So how could I improve the rule? Any ideas?
You need to subtract something.
Not this, no.
It's a limit.
Not limit, no. Not quite.
Divide it into parts, different parts.
Yeah, you could break it up into smaller parts. So for example, if you stick a point in the middle here, you could do one trapezoid here, and then you could do another trapezoid here. And then you think, well, why stop at one point in the middle? What about if I put in a few more points? So you could use the trapezoidal rule here to make an area, here to make an area, here to make an area, and then here. And then you think, well, why stop at 4 pieces? If I have the time, maybe I could make it into 8 trapezoids. And this gives us the idea that the more time you have and the more you can subdivide the shape, the more accurate your integration will be. So this formula I just showed you, that's when you only have one trapezoid. But we want to know what's the formula if you have 2 or 3 or 4 trapezoids. So let's try and figure that out from using this formula. So we'll imagine here is my B and here is my A, and I split it up into n pieces. Now on my picture I'll just draw a few pieces, so we'll say
A is starting at 0.
no, just in my picture it is, but it doesn't need to. N subdivisions.
Got it?
Mm-hmm.
Like in the first part, if you could make it like more, then it will be more.
What if in what part?
In the first part, the first curve,
Yeah.
make like 2 trapezoids and 4 more.
Well, of course, but right, of course. You take as many pieces as you want. Okay. So let's look at it like this. So we start off, we need a way to label all these pieces conveniently. So I'm going to call the first piece here, we start at A. Look up. I'm going to call this x0, that's where I start. And then this is x1, and then this is x2, etc., etc., x3, x4, x5. So what should I call the last piece?
Xn.
Xn. Okay, so if I use my rule, I can say that the total area would be area 1 plus area 2 all the way up up until area n. Yeah. Yeah? Now, before I use my rule, I want to make my rule a bit more general. So if you look at this rule here, rather than using A and B, let's just try and put in words. So B minus A, what does that represent on the original graph, B minus A?
B
A,
minus
2 minus A.
No, like, describe in words, what is B minus A?
Base.
The base. So this formula, if we were to say it in words, would be half the base. Now, FB plus FA, what does that represent here? Well, what's FA? The first height, isn't it? And FB? The second height. So FA plus FB will be the sum of the heights, the first and the second height. So in words, you could say, for a trapezoid, the area is half the base by the sum of the heights. So if I apply that logic here, the first area will be half the base. Now I don't know how big the base is. I'll just call the base their thickness h. Half the base, which is h, and the first height is x0. Yes?
The first what?
The first height is fx0,
Okay.
and the next height will be fx1.
Can you use another word for another letter for the base?
Then h.
Yes.
H is what's normally used for these.
Okay.
You want it for height, is it?
Hmm.
The next one will be half the base, which is h, and then the sum of the heights, which would be fx1 plus fx2. Come on, there we go, etc. Now, we don't know how thick the base is here, the h, but we'll get to that in a minute. First, a little bit of cleaning up. What's in common here to all the terms?
1/4
A half h. So I'll take the half h out. Firstly, we have fx0 plus fx1 plus fx1 plus fx2, and the next one will be fx2 plus fx3, etc. So what's happening here is you have x0, and then you have fx1 plus fx1, fx2 plus fx2, fx3 plus fx3. So each term is going to be written twice, except for the first and the last, because the last one doesn't have a neighbour to repeat itself. So this would be a half h fx0 plus twice fx1 plus twice fx2, etc. until the last one, which is fxn.
We have only one x2 here.
Well, I just wrote dot dot dot.
Okay.
Is it 2 minutes? Okay. 2. What? It's okay.
Yeah. It's okay, so far? actually, you know what the x0 is at least. What's x0?
That's like 0.
X0, no, x0.
Yeah, 0.
No, what's x0? A. And what's xn?
B.
B. So, to make it a little bit easier, we'll just write this as a half, or h over 2, fa plus fb plus twice, and then we add up all these pieces in between. So this would be fxi.
Yeah, sigma sign.
Yeah, and this is these are the middle pieces. I'll write middle underneath. So what I mean by middle piece is don't use the first one, don't use the last one. It's all the pieces in between A and B.
The last pair is not really good.
From here to here?
The last one, from the last pair.
Yeah, well, all I'm saying is if you see here, Karar, this is fx1, this is fx2, the next one will be fx3. So I just use the sum symbol, xi, like in semester 1. So this would be I1, I2, I3. What do we stop? When do we stop? N minus 1, yeah, because fxn, we already pulled it out here as fb. But anyways, I just wrote down middle. Okay, let's do a bit more cleaning up now. So, what is the h? How could we find the h here? Well, how big is the total length here? B minus A?
H was height, right?
No, it was not. What is KJ? It was base width. We never said h was height. I drew it as on the base. So you weren't listening to KJ's protests earlier. So how big is this B minus A? How many pieces do we have?
4.
No, in general. I know n.
Yeah.
So if I have B minus A broken into n pieces, how big is each piece? B minus A over n. So I can write this now as B minus A over 2n. FA plus FB plus twice I is 1 to n minus 1 Fxi.
I is equal to 1.
I from 1 to n minus 1, yeah. Okay? So there's only one thing left to put in. We know the A is given. True? We know the B is given. What about the N? The N is our choice for as many pieces we want. So the only thing in this formula we don't know is xi. Now if you look, if I go to the side here for a moment, if you look at my sequence of x, I start off with x0, x1, x2, x3, and I finish at xn. I start off with A. The next term is A plus H. The next one is A plus 2H. The third one is A plus 3H. You see a pattern here? So in this sequence, the nth term will be A plus NH, or the ith term will be A plus IH. And we actually know what the H is. What did we say the H was?
B minus n.
Yeah, so this would be A plus I, B minus A over n. So, this is what you might call is the term for xi, is this. Okay? So, have you got that? So, so here, I can say, this is b minus a over 2n fa plus fb plus twice I equals 1 to n minus 1 f a plus I b minus a over n close. Now you might think, that's ugly, and I don't like ugly things.
One or I.
That's an I.
Very good formula.
Yeah, well you see, because it's ugly, you might think, I want to clean this up. So there's not much cleaning you can do, but what is normal for people to do is they say, let h equals b minus a over n. So normally this formula is written with a h in it. It makes it a little bit neater. So it will be h over 2 fa plus twice the sum of fa plus, and people don't usually use I, they use a different letter, but I'll use I h plus fb. And here the I goes from 1 to n minus 1. And this here is the Trapezium rule. Let's use an example. Let's do an example, I mean. Yeah, yeah. Now this rule, it looks messy, but when you put it in words, it's not. Can I go down? Yes? So, what is this rule saying? It says, if you have some weird, difficult area to calculate, and you don't have a mathematical way to do it, what you can do is you can split it into as many pieces as you like. So let's say 4 pieces, 5 pieces, whatever. So there's, how many pieces here? 1, 2, 3, 4 pieces. So what you do, step 1 is you work out the h. What?
You don't start with the where the line starts?
I start wherever
Okay.
A, B.
Yeah.
Just a second, please. Right. I start with A, finish at B. So the first thing you do is you work out the h. How would I get the h in this example? So let's say the A and the B, let's say this is 1 and this is 50 or 51 or whatever. How would I get the height? Sorry, not the height. The base h. It is 51 minus 1 divided by, in this example, 4. Is that a number you could work out? Yeah. Then what do you do with this part? That's half of this. So can you half this number? Yeah. So what is it? That's 12.5. Whatever it is not important. Then this formula says what you do is you take the first height.
Which is 1.
No, the height. We don't know the height. So you take the first height, and then you add it.
No, half of must be half of 12.5.
All right, so it's not 12.5. What is it then? 6.25. Okay. We're not focused on the main point I'm making here, okay? So can we? No, put the calculator down. It's so not important right now. I shouldn't have put numbers in.
No, number is easy.
No, not put in numbers now. You've ruined it. Right. A, B. Okay. So can we know the height?
Yeah.
Not again.
B
Can we know the base?
Yeah.
Yes, we can know the base. Can we know half the base?
Yeah.
Yes, we can. It's a simple matter of b minus a over n over 2. Right, so the formula says you take that result and you multiply it by the first height
Okay.
plus twice the other heights, then plus the last height. So for example, I'm putting some numbers. If this height was 10, and this height was 5, and this height was 12, and this height was 11, and this height was 6, it would be 10 plus twice the other height. 10, 24, 22, and then plus the last height 6. You take that result and you multiply it by this number from the start, and you've got the area, roughly.
That's all.
That's all. So you can see, actually when you think about it, it's a pretty simple procedure. But the other slight complicated thing is, you'll need to work out these heights.
Okay.
But that's, well, if I give you the fx, you just put the numbers in. So let me do an example.
But 6 is higher than 11.
You're so missing the point here, right? Okay? Happy? Yeah? Alright. Can I do an actual example?
Yeah.
Now what I want you to do for me is, we're going to do an example where we know what the answer should be so we can compare how accurate it is. So I want everybody, this is a semester 1 problem, it should only take you 1 minute. Calculate this area underneath x squared from 0 to 1.
But now?
Yes, do it now, not tomorrow, not the next day, but now. Did you forget how to do it, or you got an answer? It should be 1 over 3. Did you get that? No, get it, come on. What's the integration here?
X cubed over
0 to 1, you got 1 over 3. Exactly 1 over 3. This is what the area should be. Yeah? Okay. Let's use our new rule. Yeah, so let's break this up into 3 pieces. Zero to 1. And we're breaking it up into 3 pieces. So it'd be, it'd be, well, let's calculate the h, okay? So the h would be, we start at 1, start at 0, finish at 1, so it'd be 1 minus 0 over, oh, that's 3 pieces, isn't it? Yeah. 1, 2, 3. How many pieces? 3. So the h is 0.333. Yeah, 1 over 3. So the first value is 0. Then when I add 0.333, what do I get? 0.333. And then when I add h again, what do I get? 0.666. And then when I add again, what do I get? 0.999, which is 1. Oh, how do I get what? No. I've just worked out the h.
Okay, that's cool.
Yes, is it? So this is the thickness.
Okay, thickness.
Yeah. So you start at 0 and you keep adding h. So this is 0, 0.333, 0.666, and 0.999, which is 1.
Those numbers are not the h, they're the point.
No. The h is the thickness. And I keep adding h to 0 to get the x points. Is that okay? How I did this? Because you need to do this for your assignment.
Yes.
It's okay? Right. So what should I get next? The height. Yeah? So I need to calculate f of 0 f of 0.33, f of 0.666, and f of 1. Well, what is this function here? It's x squared. So f of 0, what's that? 0. This one here will be 0.111. This one here is 0.444. And this last, no, don't trust me, it's okay. No, please. Seriously, no, actually do check, I'm being serious. And the last one is 1 squared, which is 1. Right, so what does the trapezoid rule say? It says that the area should be half the h, so that would be whatever half of 0.333 is, 0.1, 167? 165.
Yes, 167.
167. And then we multiply this by the first height. What's the first height? 0. Plus twice the middle height, 0.222 plus 0.888 plus 1. So, if I got my calculator, let's see how good this formula is. 0 plus 0.222 plus 0.888 plus 1 times 0.167, and I get quite respectable 352, which is really not that bad for only 3 pieces. Only 3 pieces. If you did 4 pieces, it'd be more accurate. Yeah, it's not. Well, it's not too. I mean, it's okay. Remember the true answer when we did it a moment ago should have been 1/3. I mean, it's not too far away. It's quite close to 1/3. Okay. Now, let me show you. Let's do this in. Let's do in more pieces, but let's do it like in Excel.
Why don't you use that thing you showed us or something?
No, thank you.
I might do it in ICT, yeah. Because OR can add up pieces. It can do summation, which is what I'm going to do. But I'd like to do it with everybody.
So like in class instead of Excel.
I'll do it in Excel, and then maybe in the tutorial I might do it as well in OR, and you can choose which way you want to do it in the assignment. So let's take the example I just did, okay? Let's write down the information. So what is the A? 0. What's the B? 1. And what's the N? Whatever number we want. So for the moment I'll just put in 3. But we'll change it in a minute, okay? So in our calculation, what's the first thing you need to calculate? The H, which is B minus A divided by N, which is 3 here. So that's the H we got, okay? Now what we need to do is then start marking off numbers on the x-axis. So we start off with, I'll call it first. So the first number on the x-axis is always the A. Then the next number, you add the H, don't you? So it will be the last number plus the H, and the H is a constant, isn't it? So we put the dollar signs on it. So I get this. Now how do I get the next number? Well, you add H again. So it'll be 0.666. And then how do I get the next number? Add again. Now at this point I have to stop because I've reached 1. The B. So I stop. So let's do more than 3. How many would you like? 10 it is. So, do we need to continue? Yeah, because we're not at the B yet. So next, stop. Okay. Now, how do we get the area? What's the formula? Well, let me put it here actually. Area equals, so first we do H divided by 2. Yeah. Actually, and now what I need to put out beside it is the heights. So what's the formula here? X squared, isn't it? So I'll just write in this thing squared. So that's 0 squared, which is 0. And then there's the height. What's the last height? It should be 1. Okay, so back to area here. So it's half the h times, alright, so what's first? The first height
Yes.
plus
2 times.
the last height, yeah, and then plus twice bracket, then you add up all the middle heights.
Yeah.
So that's sum all the middle heights. That's, yeah. So I should get an answer that's nearly 0.333.
This by computer maybe could be inaccurate.
Say again?
By like a machine could be like very near, like a system of computer.
Oh yeah, this is what a computer does a lot of the time. Yeah. Is this what you're asking me? Now what am I missing? Sorry, say again.
Like when we did it on the board, it was like 3.353.
Yeah,
So
yeah.
it would be like less than that.
Oh, should be.
Yeah.
Let's see what we get. Ready? So this is if you use 10 pieces.
Oh.
So 0.335. It's not too bad because the true answer should be 0.333. So it's right at 2 decimal places. Let's do 100. So I'll need to go down until I get to 1. There we go. And then I'll need to continue this down until the end. So I get to 1. And then I just need to fix the sum formula. So the last term is on C106. So that last term is C106. And then the sum is C7 to C105. 0.33335. Yeah. So you see how it approaches the correct answer the more pieces you do. And if you're using a computer software like Excel, it's not really more work to do 100 pieces or 1,000 pieces. Or 10,000, whatever. Now, we haven't talked about yet the error, because of course when you do the method this way, there is going to be a small error. If the n is bigger, what do you think will happen to the error? It should be smaller, shouldn't it? Now we can't know exactly how big the error is, because if we knew how big the error was, we'd know what the answer is. But at least we can kind of estimate what the size of the error could be. Like in physics, you know the plus minus uncertainty. So this is what we'll have a look at next. What do you need me to go back to?
No, I just need to know.
Okay, that's fine. Write down anything you need to. So do you remember when we did Newton-Raphson, I gave you a formula which tells you how many times you need to use Newton-Raphson for whatever level of accuracy you want, okay? There is something similar for the Trapezoidal Rule. There is a formula that kind of tells you how accurate you want to be, then you need to do this.
Yeah.
Okay. So, we're still on this question, okay? I'm going to park this answer. This answer here is my estimation of the area. And we all know that's a little bit too big, okay? Now, there is a formula to work out the error, which I think I want you to do, or I will want you to do. Yeah. The error, look up, that will be less than or equal to h squared all over 12n squared, the maximum the second derivative can be. Now, I'll explain how to use this formula, but it's a way to calculate what type of error you're dealing with here.
Is that n plus 1?
No. This is f second derivative max.
Okay.
What's that given? Error of what?
The error in our estimation. Yeah?
Is
that's 12 n squared.
12n squared, yeah. Okay, let's use the example. So my function, what was it? X squared. What's the derivative of x squared? 2x. And what's the second derivative? 2. So when x is between 0 and 1, what's the biggest the second derivative can be? Yeah, well, it's always 2. So the biggest is 2. So we have error. Do you remember what my h was? What was it? 0.333 squared over 12. What was my n? 3 squared. And now what's the maximum the second derivative can be? 2. Now look, where this formula comes from is too difficult to prove. But let's just see what type of number we get here. Yeah. Did I type this in? Oh, sorry, wait guys. Small typo in my formula. This is a cubed on the top, okay? No, it doesn't make more sense. It really doesn't, because the formula still doesn't mean anything to you.
But
Yes.
you know, this will be changed, like, won't be 2.
This?
Yeah, the maximum won't be 2 then.
No, it's still 2. The second derivative is still 2.
Oh, yeah, sorry.
Yeah?
The only formula change, yeah. No problem.
Yes? Okay. I think something went wrong with this formula. I don't think it's quite right.
Google.
I think I will have to. Because the number I'm getting here is too small. What did you get?
0.015.
Oh, I must be typing in something wrong then. 0.333 cubed.
Oh, okay.
Yeah, okay, try it again. KJ.
0.006.
I'm wondering if maybe I shouldn't have 12 there. Oh, I don't know anymore. Right. Trapezoidal rule. Okay. So you can see here's the formula: b minus a over 2n. The first plus twice the middle heights plus the last. So it's the same.
Error.
Yeah, this one,
B minus A.
That's what I had. The h.
But you put in at in N.
Rats!
Yes. What is n?
There's no H.
There's no n.
Only
So b minus a is 1.
formula.
And the stupid thing is, I have the formula right in front of me here. I didn't write it down right. b minus a cubed over 12n squared times second derivative. Okay, let's recalculate this. b minus a cubed over 12 times 9 times 2. Ah, that's much better. 0.019.
One.
This is the formula, guys, for the error.
Okay.
So what I'm saying now, can you look up? The area is equal to 0.352 plus or minus 0.019. Now we actually kind of know the answer already. Is it a plus or is it a minus? Well, our answer is too big, isn't it? So we're saying here that the area It's,
What's the way to get the error to be zero?
no, well, we don't know this when we do it. We know that it's somewhere between 0.333 to,
You minus it?
yeah, and then add it. Now, sometimes it underestimates, sometimes it overestimates. In this example, we fully overestimate it by the full error. So like in this example here, 0.352 was too big. Not only was it too big, it was too big by the full error amount. So we just about have a correct estimation for the area. The area is somewhere between 0.333 and 0.371. And in fact, we all know the answer. What is it? 0.333. Okay. So what's great about this method is it's not too difficult to do. It's pretty accurate, and there is a way to estimate the level of error you could be making. The last thing to do is, in the exam, they could give you the true answer and you want to know what your error is. So for example, what would be the percentage error you made here? Well, what was the true answer? It was 1/3.
You said we cannot get...
I know, but I'm saying if I gave you the true answer, you could work out the percentage error over 1/3 times 100. Isn't this it? It's the estimation minus the true value over the true value times 100.
Where did you get this true value? Where did you get the true value from?
You can't. Someone has to give it to you because you can't know it. So if I tell you the true value, we can work out the error. So that is a 5.7% error. Now I have to say, that's really good for only using n is 3. To have only a 5.7% error is actually very good. Okay. Is this formula ever 100% accurate with 0% error? Yes, in one situation. What do you think that might be?
Like when we turn like...
When the area is a rectangle.
Better than that.
100 times?
The trapezoidal is 100% accurate when the shape of the curve is a trapezoid. Of course, right? So if the curve is not a trapezoid shape, if the curve is a trapezoid shape, if the curve goes like this, and you use the trapezoid method, which takes a height, draws a straight line to the next height, it's going to be 100% accurate. Or if you have many trapezoids, and you use the trapezoid method 3 times, I'll get one trapezoid, another trapezoid, and another trapezoid. That'd be 100% right. There'd be no error. How often does that happen? Never, okay? But I'm just saying this is technically possible to be 100% right. Another situation, like you said, KJ, is if you had a rectangle shape, but then you already can easily know the area here. Yeah. Let's see if there's other stuff here.
Something like, like under the line.
Under a line, yeah. Yeah.
No, like in minus.
That's fine, that's fine. The trapezoid rule is used to calculate the integration, not the area. So if it's under, and your answer is negative, and that's fine. So don't worry about negatives.
For example?
No, I understand what negative is.
I know.
No, I know what you're saying. You're like this, yeah?
Yeah.
Yeah, so
How
that
would you?
you would use negative heights in your formula and positive heights this part. You don't make any change. Now, that's to get the integration. The integration. If the question asked you specifically for the area, then all you do is flip your negative heights to positive heights.
So that's absolute.
That'd be absolute heights, yeah. Yeah.
We can't do this.
Yeah, but I don't think this is what's going to happen in the exam. In the exam, they're going to give you an integration, which could be positive, could be negative. It doesn't matter. If it's negative, and you use negative heights. If they ask you for the area, which I don't think they will, then you'll need to make the negative heights positive heights, which just means flipping it around. Take the pen out of the hair, please. Some maths problems can only be solved using this method. So one example I gave you at the start was e power x squared. Another important example would be something like sine x over x cannot be integrated. And another important example is 1 over log x. This cannot be integrated. So you must use a numerical method. Okay. Now, by the way, guys, just by the way, that guys, you know this is important for your assignment,
I know.
and you know it's important for your exam, and you know it's important to me. So be quiet, please. Okay. So this error formula here, this part here, the b minus a, is easy to calculate. So is the n. This maximum second derivative can be a little bit difficult to calculate, but it's all right if you just kind of estimate it. So for example, imagine we had a function like something like I don't know.
X minus.
Yeah, okay, let's just say x cubed. So then you have 3x squared, and then you would have 6x. Now you might say, oh, what's the biggest 6x can be? Well, it could be infinite, right? But if you think about it, it can't be infinite between the values of a and b. A was 0 and b was 1. So what's the biggest 6x can be between 0 and 1? 6. Because the biggest happens where? At the end. Yeah? Now, if you have no idea what the biggest could be, if you haven't a clue what the biggest value could be, you could kind of just roughly estimate the biggest value by looking at what's its value at the start, look at its value at the end, and just take whichever of the two is bigger. Of course, this doesn't always work because maybe the biggest value was in the middle, but usually not. I mean, usually for these types of problems, the biggest value is usually at the start or at the end, because in the exam, what they usually do is give you curves which are increasing or which are decreasing. So it's kind of clear that the biggest happens at the start or the end of the interval. Okay. In the rare situation that it doesn't, in the rare situation that it goes from small to big back to small, what you could do to estimate the maximum value is just pick the number in the middle and get the value of the second derivative at that point. Now that, again, it's just estimation. You would just like to know roughly how much of an error you could have made. Okay. In fact, this formula is not on the exam.
Just for our assignment.
You can talk about it in your assignment, and some of my questions ask you about this formula, but in the exam they won't do that. In the exam they will make you stop here. But what they might do in the exam is they might give you the true value and then ask you for the percentage error. They could do this in the exam. So this is very important for the exam. Because this is a new topic to the syllabus, okay?
Yeah, he's calculated.
Okay, fine. Because this is a new topic to the syllabus, it really makes me think that it will definitely be on your exam because it's new. There are 2 new topics this year. So I'm pretty confident that both those topics will be on your exam because they are new. This is usually what happens at school and university. Whenever there's a new topic, it's going to be on the exam because then what was the point in adding it that year? So the people who told me this is a new topic and the people who make the exam, they're the same people. Right? So they're not going to say this is a new topic and then not put it on the exam because that would be crazy. So it's very important for your assignment and your exam. So I want to give you a few minutes to try to do number 2. Okay? Try number 2 before you go. I want you to use the Trapezoidal Rule to calculate the integration of e to the minus x squared. And let me give you a little hint. You might see this type of function again nearly sometime this week. You might see on a piece of paper, and it'll be given to you this week, a problem that has something to do with this, e to the minus x squared. Okay, so make sure you can do that one for sure. Now you do understand, it's just you don't want to understand. Can you put the light on, Yemi, please?